Okay, so how's it going? Ready? So when we got back from our last lab exam, the first thing we did was a lab I called echinoderms and oddballs, right? Right? So we did have from the very end, if you need to go back to a previous slide thing, I had one slide of these little guys. Water bears, tardigrada, and Arnicophora. Those are the two phyla that were kind of oddballs. And the reason why I chose to move them over to our lab exam 3 and not have them in lab exam 2 is you probably would have called these something they're not, right? The Arnicophora looks kind of like a polychaete worm, but it's not. It's a velvet worm. It's its own phylum. It's been around for 500 or more million years in fossil record. And then we have on the left the phylum Tardigrada, which kind of looks like maybe some sort of an arthropod or maybe some sort of a polychaete worm of some kind. But basically, these are two unique phyla, and the thing they have in common is their closest relative is the Arthropoda. They're, as the name implies, almost arthropods. They have an exoskeleton, they have a cuticle that kind of operates like an exocuticle, like a nematode has. Very similar cuticle, like what a nematode has. But they have fleshy legs, but there's no jointed appendages. There's no exoskeleton or chitin on these, which is why they're not classified as arthropods. So probably at one station, I'll have a slide with a water bear on it, Tardigrada, and maybe next to it the little block that has the little velvet worm embedded in the plastic block. And I'll ask you what the phylum name for those two things are. And the additional question will probably be, what phylum are they most closely related to? You should write arthropods, right? They're basically not worms. They're arthropod relatives. Okay? You don't need to say why, but the reason why is because they have an exocuticle that's very similar to what arthropods and nematodes have. All right, so that slide was on the arthropod lecture slide. You can still access that. It's just buried down at the bottom of your canvas. All right? Okay, then we went into the echinoderms. The other oddballs that we need to talk about, in addition to the tardigrades and Onychophora, which you might think were worms but are actually arthropod relatives, we have these bryozoans. The phylum Bryozoa is a colonial filter feeding thing, and you probably would have classified this as maybe a sponge or as a coral or something. But it's its own thing, phylum Bryozoa, and I'll probably have a station that has a microscope with Plumatella, which looks a lot like this. Plumatella has these little individuals on them. And the main thing to note is their feeding structure is also a gill. It's a gill/feeding structure that's called a lophophore. The lophophore is kind of the key term here. And so it's the phylum Bryozoa, the lophophore is the feeding structure, and then I told you there would be an extra credit question, which is the species name for the big jelly ball that occurs in Shasta Lake. Sometimes you can find them in Whiskey Town or in ponds. Jasper Lake where you mostly see them. If you need that species name, you can maybe ask someone who wrote it down. Okay. So, any questions? Oh, the species name has to be spelled correctly, and it has to be written in a correct genus species format, right? And what that means is the genus has to be capitalized, the first letter is capitalized. So the first letter of genus is capitalized, the first letter of the species is lowercase, and they have to be underlined. And it should be underlined separately, not underlined altogether. So I specifically on this part of the question, don't put a line down for you to write your answer, because students then think, oh, you already put a line for me, you know. But I want you to write the species name and the genus and species, and because you're handwriting it, it should be underlined. So it's got to be spelled correctly. It has to be a capitalized genus first letter, lowercase species first letter, and you got to have them underlined. All right, to get your 2 extra credit points. Got it? That shouldn't be too hard. Okay. Any questions about Rhizoa? Anything else I could ask about them? I don't know. Probably the phylum, the feeding structure, and the extra credit question. Got
Oh,
it?
you have the stratoblast.
Okay. We also had another oddball that you probably would have classified as a bivalve mollusk, but it's in fact its own thing called the phylum Brachiopoda, and they're a kind of a deep ocean bottom dwelling plant-living thing, and they are also a lophophore tentacle filter feeder and gill. So they have a lophophore as well. On this one, I'll probably also ask a little bit about orientation. And you should note that the pedicle, what you would call a foot in the mollusk, but it's not really a foot here, it's what's called a pedicle, is posterior and dorsal. So when you see these, basically the short shell where the pedicle is sticking out is the dorsal side, and the pedicle is on the posterior side. So the gape or the opening is actually anterior. So it's a totally different orientation than what the bivalve is. So I think over there, if you look in the cabinet, there is a little jar that has these in it. One of them has a little piece of tape on it. Letter A, and that'll give you a hint as to kind of what the question will be, right? So the little pedicle foot is posterior and sticking out the dorsal side of the shell. Got it? Any questions? So oddballs because they look like something else. That's why I put them on this test and not the last test. Okay, then we had echinoderms, and certainly I'll have probably all of these classes on the test in some place. I'll probably put the sea star at its own station, the Asteroidea, because the Asteroidea also had that little structure on top called the madreporite. So if you remember the little disc that you find on top of these, it was pretty mostly obvious on the ochre sea star, orange ones. So I'll probably have an ochre sea star. I'll have a pin in that structure with the madreporite. And the madreporite is an opening to the water skeleton, right? That's basically when they retract all their 2 feet, water pressure would build up in this water skeleton, so water can actually vent out the madreporite. Or when they extend their 2 feet, they need more volume, so they'll pull water into the madreporite. So this is basically like a vent of the water skeleton system. So a couple questions that are interesting about echinoderms. First off, the phylum name, Echinodermata, and that means spiny skin. They have 2 separate skeletal systems. They have an exoskeleton, it's made of calcium carbonate, and then they have a water skeleton that they use for movement. So they kind of have a unique dual skeletal system. Other interesting things is their symmetry is they have a pentaradial symmetry. It's a unique symmetry that's kind of like a 5-sided symmetry. And So they're not really radially symmetrical at all. They kind of have a fake radial symmetry. But it's called pentaradial symmetry for this group. That's a unique thing. What else was it? The Asteroidea were mostly predators. There's all kinds of things I can ask about structures, so I'll hold one by itself. And then the extra credit question was the species name for that ochre sea star. And there it is right there, Pisaster ocraceus. That's how a species name is correctly written. Because it's typed, I italicized it. If I hand wrote it, I'd have to underline it. That's kind of the deal. So again, for the extra credit, it has to be written correctly, capital first letter, lowercase species name, and it has to be spelled correctly and underlined, right? Okay, so, and then I'll probably have a separate station with a sea urchin or sand dollar, or maybe both sea urchin and sand dollar, because both sea urchin and sand dollar is in the sea urchin and sand dollar are in the class Echinoidea. And let's see, what good questions about them? Oh, remember the little vial for the sand dollar, the little doves that are in there? So you should know what those are called. That's their beak, or it's also called the Aristotle's lantern of the sand dollar. And the Echinoidea are mostly herbivores. They're mostly grazers. They graze on algae and seaweed and microalgae. Got it? So I'll probably have separate stations for the sea star for all those questions. The sea urchin and the sand dollar will probably be together on one station. And then maybe I'll have a combined station with a turtle star and a sea cucumber, just so I can get you to remember the class name. The class name for the turtle star is the Ophiuroidea, and the class name for the cucumber is the Holothuridia. So that's probably 3 stations for a predator there. Got it? Okay, cool. Anything else about echinoderms? I don't know. Sounds good. Okay, all right. So then, anything real cool? So then I went into embryology of these things. And with the embryology, we talked about, where is my embryology slide? For embryology, I went through various stages of embryological development. The key stages that I'm most interested in are the ones that are like major steps. So remember I'm not going to have an egg. I can only ask a few questions about the egg and the fertilized egg and the fertilization. So I won't have just the egg or the 1 cell, but the stage that was the most interesting was the 8-cell stage. Because the 8-cell stage is where we had differentiation between spiral cleavage and radial cleavage, right? So radial cleavage or radial development in the 8-cell is one major group of organisms, animals, and then spiral development or spiral cleavage is a whole other major group of animals. So I'll have you recognize, I'll probably have both of them on the test. And remember that radial cleavage you can tell because all 8 cells are about the same size, and they're kind of like stacked like a cube. And then in spiral cleavage, the 4 new cells are much smaller than the 4 prior cells. And so it looks kind of like 4 cells with 4 dots in the middle. And so you should be able to recognize they're both 8-cell stage. I don't know why, but in years past, when I put the 8-cell stage there, students will say it's the 3rd stage. And I'm like, what? What does 3rd stage mean? What they mean is there's 1 cell, 2 cell, 4 cell, 8 cell. So they're kind of calling it like the 3rd or 4th stage. But be sure you label it properly. It's the 8-cell stage because that's the major thing. I don't know where that came from. I always felt bad about what was wrong. But and then you need to identify whether it's radial cleavage or spiral cleavage. Now remember, in the radial cleavage organisms, those were usually deuterostomes. And in the spiral cleavage organisms, those were usually protostomes. That's kind of the major pattern, right? Questions? Okay. So after the 8-cell stage, certainly there's going to be both a spiral and a radial cleavage on the test. You don't have to answer those questions. There was the blastula stage, was the next major stage. I know I mentioned a morula stage, but there's not much I can ask about the blastula stage. The blastula stage is more interesting because the blastula stage has this cavity in the middle called the blastocele, and I think I had indicated that the blastocele basically disappears, or it goes away, or it's replaced by mesoderm in the coelom. So that blastocele, cavity in the middle of the embryo, it basically disappears and is replaced by mesoderm in the coelom structure. The blastocele does not become the coelom. Make sense? And it's kind of like a nuanced thing. But the coelom doesn't come from the blastocele. The coelom comes from, in deuterostomes, from out pockets in the gut. And in protostomes, it comes from dissocially, which is the splitting of the mesoderm. So the coelom derives from mesoderm, basically, for the gut. And the blastocele basically sort of goes away. Got it? Okay, so there's definitely going to be a blastula stage on there, so you should know what's blastula. I don't care how many cells it is, because blastula is like, anything from 30-something cells to 100-something cells. And then, well, the next stage that I'm concerned about is the gastro stage, or gastrulation. There'll probably be a stage that has various levels of gastrulation, and specifically I'm interested in that first little pocket, that what's called the arc enteron. The arc enteron is where the blastula stage basically gets this little divot or this dent in it, and where that divot or dent forms, that is where the gut tract is forming. It's also where endoderm derives. So a major important stage in life is that gastrulation. Oh no, you thought high school graduation or your wedding was the most important day of your life. No. Gastrulation was the most important day of your life. And so anyway, because if that goes wrong, you don't want to be born, right? So anyway, the idea there is that this little invagination is the beginning of the gut tract. In deuterostomes, that will be the anus forming. Deuterostome means second mouth. And in protostomes, the mouth forming. But basically, the final embryo kind of looks the same, meaning it has a tube within a tube type design. So, any questions on that? So I'll probably have gastro stage, and I'll specifically have a teacher have
I saw the black stuff. It was
got it? Anything else I got for that? Yeah. So 8-cell stage for the starfish, blastula, gastrula, and then maybe an 8-cell stage for the spiral cleavage. So 4 different embryology stations, right? Get the idea? Okay, cool. All right. I think that's it for embryology. I think you start with it. Okay. Then we get into the primitive chordates. So the chordata, this is what the bulk of the test is on, is chordates and vertebrates. The chordata has a couple key features, so you should know what the basic features of the chordata are. And I believe I mentioned that it's a notochord, a dorsal notochord, right? A stiffening cord in the tail. And then there's a dorsal nerve, and then there's pharyngeal gills, gills on the pharynx. There's a fourth one that I mentioned, but I think it's lame. So let's go ahead and stick with the pharyngeal gills, dorsal nerve, and notochord is the key features of the chordata. So these all 3 of these have that. So for the tunicata, I'll probably have two different stations for this. One will have the larval stage, which has all of the chordate features. The main thing here is that the tail is where the notochord and the nerve cord are located. You can see those in the tail, and the tunic is where the pharyngeal gill is located. So I'll probably have a microscope with a little Cional larvae, a little tunicate larvae in it, and that's the only stage that has all the chordate features. The next station will have an adult tunicate, probably that one that has a long stalk on it, styla. I think I had it in a dish here with its tunic open. And remember that in the adult, it only has the pharyngeal gill left. So the gill is the only thing that remains in the adult. The dorsal nerve and the notochord will disappear in the adult stage. So, and that bag that surrounds the pharynx is called the tunic. So, not super mysterious because that's where the name comes from, tunicata. The tunic just means like a cloak or a body cover, right? Who here have a tunic? Hard have a tunic, right? You know, hooded sweater or something, right? Okay. All right, so then we have these little anchovy-looking things called the lancelets, or amphioxus. You'll have to know, though, the subphylum name, Cephalochordata. What that means is the notochord goes all the way to the head. Cephalon is the head, chordata means notochord. So these were interesting in that they had kind of an interesting filter feeding setup. So I'll probably have these on a dissecting scope because they're so big. It's kind of hard to see a whole one in a compound microscope. So the main thing to note here is that they have these pharyngeal gills that have like 30 or 40 gill arches on them. And then the notochord goes all the way to the head, like I said before. And then they have this outer cavity around the pharynx called an atrium. So that was kind of the unique features of these. They have this kind of atrium feeding type structure. So the food comes into the middle of the pharynx. Here's the middle of the pharynx here in the cross section. And then the water is filtered across the gill arch. And this outer cavity here is the atrium there. And that's kind of the key thing there. And then the interesting thing about these is the notochord and the nerve cord are stacked. The nerve cord on top of the notochord, but they're not the same structure. They're still separate units or separate entities. And that is opposed to the lamprey, which in the lamprey, they have a vertebral or a vertebrae that encases the nerve cord and the notochord together. That's what a vertebrae basically is, a notochord and a nerve cord kind of combined into one little package. All right, so what you probably confuse is this cross section, which has separate notochord and nerve cord, with this cross section, which has notochord and nerve cord are together. How you can tell they're together is there is the nerve cord there, and then this is the neural arch, or this cavity. And the notochord looks the same, but you'll tell because this one has kind of more frilly gills, and there's no atrium around here. So this is the lamprey cross section. The lamprey larvae also is pretty obvious because it has a distinct 7 gill arches, and you can see those there. So probably on the lamprey, yeah. So you'll have to differentiate between the amphioxus, which is the cephalochordata, and I'll probably, along with the one on the microscope, have some little ones in addition to look at. I won't ask any questions about the subphylum name, but most of the questions will basically be on the microscope specimen or the cross section. Got it? Okay. I know there's some extra arrows here, but don't worry about like that one is the little padded cecum. I'm going to ask you that. I'm mostly interested in the pharynx and the atrium, the notochord and nerve cord. So here's the pharynx, the atrium, notochord and nerve cord. I think this is pointing to the nerve cord. There. And then this is pointing to the notochord going to the tip of the head. Okay, so you'll have to recognize the hagfish versus the lamprey. And remember the hagfish typically has like, I think it's like a dozen or so gill slits on it. And it doesn't have a little tooth sucker mouth. But the class Myxine is for the hagfish. And the thing you should remember about them is, even though I'm classifying them in the subphylum Vertebrata, they actually don't have a vertebrae. So I think I made a big stink during this lab about how this subphylum should probably be called the Craniata, because the hagfish has a cranium, but it doesn't have a vertebrae. And so we're kind of artificially putting it in the Vertebrata, even though it doesn't have a vertebrae. So you should know that. Okay, so it's the class Myxine, hagfish lacks a vertebrae, and that's what makes it basically different from the Hyperarchia, which is the lamprey. They have a vertebrae. Got it? So on the lamprey, you should just know the subphylum name. You should know, both the hagfish and the lamprey are classified, or they're generally considered to be in the group called the Agnatha. And even though it's not a true classification name because it's a primitive feature, Agnatha means jawless, right? So you should know that the hagfish and the lamprey are the jawless fishes. Kind of a key thing. Sound good? Okay, you probably have a station that has a hagfish in the jar and the little lamprey juveniles in the jar. Have you identify the subphylum name for both, and then identify if they're jawless fish. Probably there I'd ask you about what feature does the hagfish lack that the lamprey has, and that's a vertebrae. Okay. I think we're looking good. So any questions on the primitive chordates? Got it? Okay. We're just cranking. Vertebrates. Okay, so these, when I say the vertebrates, what I'm referring to is the jawed vertebrates. So his classification is, we already covered the Myxine and the Hyperarchia, which is this group that I'm calling the Agnatha. It's enclosed because it's not a true taxonomic name, just classifying them as the jawless fishes. Everything else here is the jawed vertebrates. And so that's what we're calling kind of this group here. So starting with the fishes, the cartilaginous fish and the bony fish, that was one lab. And so you will have some shark jaws on the desk. I think they're over there in the cabinet. I think they're even labeled as to what I asked on them, right? So the mandibular arch is the front arch with the teeth on it. You should also know that the teeth are derived from scales. They're modified placoid scales or dermal denticles. You could just say modified scales is what the teeth are made of. And that mandibular arch is the first gill arch from lamprey. It's the gill arch number 1 is modified into the mandible. Gill arch number 2 is modified into this hyoid or hyomandible, and it's a support arch, kind of like a bicycle frame. It kind of gives a little bit of rigidity or support to the mandible arch. And so on the other shark jaw I have the hyoid label, and it's a little arch behind the mandible. So the mandibular arch, the hyoid arch, and the teeth I'll have probably 2 different jaws there labeled. They're up in the cabinet labeled. So make sure you see those. And let's see here. I think that's it for that one. But known as the mandible and the hyoid are modified gills.
GNATHO.
Got it? Okay, and then the bony fish, the Osteichthyes,
Yeah.
these basically have replaced the cartilage with bone. And the other feature they have that's unique is a skull. The bony fish skull was unique. So I had a snakehead skull, and so it has a cranium. The TMJ, the temporomandibular joint, the cartilage is the remnant of the mandibular arch. The ossicles are the hyoid bone, is the hyoid arch. And the third gill arch is called the operculum, which is covering the remaining 4 gills. So I think it's pretty cool that it has this kind of homology, similar structure, but modified in the future. I won't have a dissected bony fish because we didn't do it in class, but you should know that the bony fishes use a swim bladder for buoyancy, and the cartilaginous fishes don't. Right? So then there'll be some shark dissections, probably a couple sharks on the test. I think we went through some of the main things the shark would be good to ask about. But I think the shark had a pretty good stomach, duodenum, ileum, and rectal gland, right? I think I said the rectal gland was probably a good thing to ask because it was unique to the shark. I think the shark also had the best pancreas because it was preserved and looked pretty obvious and easy to pin. So if I ask about pancreas, I'll probably the shark. All right. Yes. I'm not.
I think we had the best
Don't
shirt.
hold me to it.
We had the
But
best shirt.
the pancreas and the shark was probably the easiest
Yeah,
for
they
me to
were
stay
one of the
pinned
sweet.
to have it be
Yeah.
consistent from student to student. Whereas the rat, pancreas, because it's so fresh, it's kind of bubble gummy. It doesn't want to stick to it. And then the frog, pancreas was kind of shredded and, not easy to put a skin into. The shark pancreas is the easiest one to do. Just hint, right? Anything else about the shark? So we have the stomach, duodenum, ileum, rectal gland, pancreas, spleen on the shark was all right. Kidneys in the back wall. Then we had the heart, with a 2-chamber heart with 1 ventricle and 1 atrium, right? I think that was pretty much it for the shark, right? That was kind of all the questions I might ask. So plan on maybe 2 shark dissections. Each one will have like 3 or 4 things asked on it. Sound good? Right. Then we got into the amphibians. So might be a station that has a frog and a salamander. And remember, the classification really is just more about whether it is a caudata, meaning a tailed amphibian, versus anura, which is a non-tailed amphibian. But I don't know. We'll see if I can put that on there or not. But the frog dissection was the main one. And in the frog dissection, I'll use your frogs. I think we had a good stomach, duodenum, ileum. In this case, we had a colon, which was a kind of a new feature. And then the kidneys were good. I think the spleen was pretty cool in the frog. It looked like a little cranberry size thing. Time for Thanksgiving. And then the heart had a single ventricle, a right atrium and a left atrium, and then we had lungs, right? So those are all good features to show on the frog. So certainly 1 frog, maybe 2 frogs, depending on how many questions I come up with. Second, right? So questions there? Okay. So let's see here. That was it on the frog. Looks good. Okay. Let's see, okay, reptiles. you know, we didn't really cover much on reptiles, but I will have a station that has probably a turtle skull, an alligator skull, and a bird skull. And you're gonna have to tell me what the classification is. The current classification is the turtle and the alligator are in the reptilia, and the bird is in the aves, right? But you should also know that the turtle skull is an anapsid skull, and that the alligator and the bird skull are diapsid skulls. In fact, they're even more closely related to Archosaurus. So I think it's interesting is that we have a classification that doesn't really match the evolutionary history. And it's just purely because of it's hard to change these classifications that have been used so long. So I think I showed you that here. They're right here actually. We have a turtle skull, an alligator skull, and a heron skull. And so you should know that this one is, these two are reptilia, and this one's aves, but this one is an anapsid, and these two are diapsid, right? So it's like a shell game, which one belongs, right? So anyway, that's kind of the interesting story is that the current classification, even though I won't ask the name Archosaurus, the current classification puts the alligators and the birds together into this group called the Archosaurus, but it hasn't quite fully happened yet, so we're not going to use that as a name yet. We'll go ahead and still call the alligator reptiles. Okay, so that's kind of our example here. Probably a separate example would be that the mammal is a synapsid skull, and that means that it has one temporal opening, and that's what the one jaw muscle that goes under the cheekbone is the example of the synapsid skull. Okay, let's see, what else? So for the reptiles, I think that's pretty much all we're going to do for reptiles is have these skulls on there. I'm not going to have a snake right in the jar. But I will have a rat dissection. And the rat dissection basically will be, there's one rat. I'm only going to use one rat. And I'll probably focus on things that the other organisms didn't have. The diaphragm was a major one, right? Just count on the diaphragm being and have them identify it, right? I might even make it like letter D.
That would be nice.
Okay. So, and then what else? How about like the C? How about I make that letter C?
The diaphragm. I just remember like.
What a nice guy.
Yeah.
What's letter A and B? What do you want for letter B?
Yeah. I think we'll be good.
And no, but it's not a true.
Yeah, it's right below the face. So
Letter
it's
B
below.
would be like maybe.
Yeah, that's how I have it drawn.
Maybe like.
And then the liver is on
What's
the
that?
side.
Oh boy, man, you're hard.
These are
I should
touching
have
the
you make
liver.
that. Did anyone see the air church? Wow, man. Okay. What other letter B could be? How about like
Bladder. B for bladder.
B for brain?
B for bladder.
Have you
Right
seen
next to the
brain?
bladder.
Okay, I don't know. One other thing, like what did the rat have? Okay, maybe how about the kidney? Rat. Kidney was pretty good, right? I mean, I'm not going to promise it's going to be, but you know, I mean, kidney would be good for the rat because, right? It was like the kidney and the shark was like embedded in the back wall. It wasn't like a structure, it was like a part, like a place,
Yeah.
right? And the frog had okay kidney, but the rat had a really, you know, nice one.
Obvious kidney.
And then, liver's too easy. How about letter A? Maybe like the right atrium or something like that? Ooh. Wow, that'd be good. Or left atrium. You have to figure out which one.
It's just opposite. Because if they were
Okay, anyway, you get the idea though, is I'm gonna have one rat, probably only 4 things labeled on it. So what you gotta think about is what would be the
I
most
can't really
likely
see the
thing?
dividing line that he was talking about.
Yeah, I can
Probably
kind
not
of
the
see
liver.
like a lighter
That's the
side.
Yeah, but it was kind of like half of it was
Okay,
lighter
questions
instead
on
of like
that?
more of a
And then in
line.
addition to that, you know, I might ask a question, maybe with the coyote
Yeah.
skull here, or dog skull, whatever it is, ask you a
Wait, is
question
he gonna? I
about
don't
mammal
think so. I'm
features.
just gonna stick it in my
Namely, mammal features are they have hair,
If it's facing
Hair is a
you,
unique
it's
feature of
probably the
mammals.
right atrium.
Mammary
Or if it's
glands,
like from the back, it's probably the
you know,
left.
live birth, and a synapse and skull is kind of what makes. So, and then finally, I think we had a bird on there. Don't forget that in birds, the feathers are actually modified scales. The birds
Yeah.
have a modified
Feathers are
scale,
good.
is what feathers are derived from.
Oh.
There we go. I think that kind of wraps up all of our stuff, right? Sound good? Okay. So, hey, Thursday, 9 o'clock, you know, be ready at 9 in the hallway. If the door opens at 9:05, don't panic, you know? Not In-N-Out Burger.
I have 20 minutes to wait.
So, I get here super early to try to get everything fresh.
Yeah,
And
but I
usually
still
have
leave it.
like
I leave my
rat
house at the
lab.
same time in case there's
So just
traffic.
fresh,
So
you know?
oh,
And so.
I actually have an hour.
I try to get
still
the
wait
door
for it.
open as close to 9 as possible. But if it's a few minutes after 9, just please be patient.
Does he like?
Successful only
Because I
takes you
almost
about an
feel
hour
like he
to go
does the
through,
dissection
less than an
and then
hour.
prints out the labs.
Because we're only gonna have like 20,
Because like
25 stages.
he pins it.
So it's gonna be under an hour. And then
Which
you'll
is
have time to
wild.
go back, all right?
Imagine like typing out and
All right, so you're welcome
dissecting
to
something.
look at critter specimens or ask me to show you something.
Bye, Betty.
But otherwise, we'll see you on the.
Do you have any allergies? I was thinking about making butt cookies. Do you like chocolate and mint?
Oh, yes. Like Girl Scout cookies? Emmets?
I'm gonna make like chocolate crackle cookies with Hershey Kisses.
That sounds pretty good. I like pretty much anything sweet.